Hi, everybody. I'm Michele Bustamante, and I have a company called Alliance. I do a lot of architecture consulting, cloud and security focused. We specialize in all things, I guess, cloud and otherwise, but I particularly run a cloud practice where we've built up quite a bit of microservices talent with many different platforms, and all of that, of course, is founded on Docker, at least in our work together. And I'm going to talk to you a little bit about building Docker applications for Windows, but also cross-targeting Linux or Windows. So looking at some of the tools with Visual Studio that are new. They've actually just released some stuff this week, so all my demos are going to work. And that's all I have to say about that. So we first should talk a little bit about why Docker. And of course, you've probably heard a lot of stories about why Docker is helpful, useful, powerful. I would say I'd start with it enables microservices architecture, which of course is another buzzword that people hear all the time. And I will start by saying not everybody needs a microservices architecture, of course. And so this is overloaded, often talked about for things that are not requiring it, but that doesn't mean you can't still apply Docker without going full on microservices. So it enables microservices architecture, and the reason we go towards that path is for the flexibility of faster release schedules, enabling your applications to be deployed, frequently updated, with less regression, of course, over the whole application. And the reason we want that is because the business cares. It's all about the business. If it is valuable to your business to have a microservices architecture, then going forward in this path with some form of baby steps, which I'll talk about in my second talk today, will probably be beneficial. And how far you need to go might depend on scale, size of solution, and desperate need for the type of things microservices solves in terms of problems while creating new ones. Faster release cycles is the main thing that the business will benefit from, and that's why we usually look first to the business to see, is this going to be valuable? Docker enables this because, of course, it's supported by a lot of the platforms that enable microservices applications. Why we like Docker also is because it gives us a polyglot development environment. I can have developers that do Golang or Java or Dropwizard, different forms of Java, .NET applications, Node and Python, and use the right tool for the right job, as they like to say. And then at the same time, be able to compose those applications together, or those moving parts, those components, in an orchestrated solution. And so the fact that we can enable that with containers is really powerful. And I would say beyond that, it's also highly powerful because of the developer workflows that it enables. So if I would say I use this probably on a daily basis, and it's one of the most powerful things I can do with Docker, and that is have a new team member join a project and literally say, install Docker and run, get the latest repo and run compose up. And what that does is it gives them literally a complete, for example, back end to the front end that we might be debugging in Visual Studio or some other tooling. And I don't have to have them install, SQL, event store, run scripts, do migrations, all the things that just waste time and cost a lot of dollars when you need to set up a new machine. So I would say compose up, one of my number one favorite things to do, just even in development, if you're not even using Docker for a deployed solution at this time. It's highly useful in development. And of course, with the microservices target, the target goal of a microservice-enabled solution, we are probably looking at a lot more moving parts, a lot more updates to the release cycle, smaller components, of course, that are composed together, and that means we have more complexity. And with that complexity, including in the orchestration platforms and the management of those, we, of course, are hoping to get some gain on the other side, which is where the business has to be behind it. Otherwise, you will fail. So the business behind you, you have a target goal, you build a microservices solution, you start targeting platforms, you need a DevOps culture to survive that. If you do not have high availability, disaster recovery, visibility into logs, great dashboards for managing things, and knowing when something's wrong, self-healing, and drills against those things to know how does the system behave when we make failure happen. It's a lot of work up front. The payoff is on the other side. You spend a lot of money early. Am I selling you on this yet? You spend a lot of money early for the gain later, but the first 8 months is a lot of work, right? No pain, no gain. And so what we're looking for is that resiliency that comes with the other side of that effort, which is, oh, look at this. I've got great logs. I've got instrumentation. I've got end-to-end activity tracing, all these things that I probably should have been doing anyways with all of my applications, but now I'm forced to do, or I literally won't survive the microservices movement. So with that, Docker enables all of this. What does this mean to a .NET developer? Obviously, it means something to other developers too, but we're focusing on the .NET tooling. Number one, you can run your .NET framework legacy applications. Let's call them legacy now, because of course Core's been out for at least a week, 2.0. So .NET framework applications, can run in Windows containers, and that means that I can literally, with very little changes to the app, have that be deployed alongside other containerized parts of the solution, and then later migrate the monolith into something a bit more palatable, something that's better factored, and so on. So I can still get that thing into the cloud, migrate to the cloud more easily. There's lots of things we can think about there. We didn't have that before Windows containers because, of course, .NET apps would have to be fully rewritten into AspNetCore to go to a Linux-based image. So creating new applications, we can go with .NET Core, and we can target either Linux or Windows. A lot of people target Linux just because a lot of the container platforms are very mature on Linux. But of course, that is starting to evolve and change. And it also changes with the need to have a mixture of legacy and modernized applications. So now we care more about having one container platform that's maybe focusing on Windows VMs instead. And so we can decide that's what I'm targeting, if that's my culture, if that's my need. So the fact that I can build new apps and target Linux or Windows, depending on what we're trying to achieve, the fact that I can take my legacy apps, and then, of course, have that same development experience I'm used to today. I'm in Visual Studio, I have F5 debugging experiences, and I also have tooling to help me enable the Docker experience. So now, the heart of all of this would be that I'm taking an app and I am building an image for that app, and I have to have a base image that's compatible with my target environment. So if it's going to be Linux, then I choose a Linux-based image. If it's going to be Windows, then likewise a Windows-based image. So in the Docker store, which used to be called Docker Hub, we actually have images, just a smattering put here. The nano server image, which is the smaller form factor image that would support, your Linux equivalents, let's say, but targeting Windows. Lightweight. And then we've got Windows Server Core, which would support our IIS-based deployments. And so, of course, I'll need a heavier image that has a lot more moving parts to support those legacy applications. And then we've got an IIS image, which has pre-deployed IIS. So, of course, that's now the layering aspect we get into, which is which image should I choose? If I would like to go with a raw Windows image and install the other things myself, then I can build my own layered images on top. If I would like to use something that's vetted and blessed by Microsoft and then build on top of that, then I can choose one from the store. So the Windows images are here, and then we also have the Linux-based images that have AspNetCore enabled, ready to go. So you would choose one of those images, and that would light up deploying Kestrel-based access, for example, instead of IIS, right? So I'd have a web server or a reverse proxy for that. I can deploy just .NET applications if they're going to be some sort of projector or console type thing, some process that runs, no need for a web server. And then, of course, there's even build containers. And the build containers enable us to have a drop to command line experience and or automation experience for building the images without having to set up a bunch of things on my CI server even to do so. So, for example, Jenkins can take advantage of using some of these build images just like I can in my own dev environment. And then, of course, we have layers on top of that, having source code, SDKs built into some of the images, and then things like SQL Server variations. No, I'm not going to deploy a clustered SQL solution with containers. Data in containers is not generally a recommended approach in most cases. You want data clusters running on hard metal. But I would say this is extremely useful for development, and it can be useful for smaller deployments that only really need something that will run most of the time. You might be one of those people, but you won't admit it. So sometimes people deploy stuff and they're just a startup and they need it up and running. That's an easy way to do so. I just wouldn't recommend it for long term, right? So we have these images. You can go to the store and choose from them, but we will see that we're going to choose them as part of working with the tooling that comes out of Visual Studio. Of course, with the whole support for legacy .NET applications, we now have the ability to port all of these legacy applications, and they could be WCF-based, they could be different versions of ASP.NET. Anybody in here has ever had an old version of ASP.NET applications running, maybe, you know, pre-4.5? You know, it happens. And so, you know, you can build a container that has exactly that. So just for some examples, you can take the IIS Docker file, and this illustrates things like you can add Windows features. So this shows adding the Windows feature of IIS, but of course you could also have features your app needs. This is the kind of thing you would do as part of your Docker file description. You can do things like Service Monitor is the entry point for keeping IIS alive in the container. You can copy over source or executables and run them as part of the launch of the container, so you can describe that in your Docker file too. Things that you can do that legacy apps might need, or even other apps, right? So this is important to know. ASP.NET 3.5, this is an example Docker file that has that is based on 3.5, just to show that that can work too. And this also has things like .NET FX3 being deployed, so I can do things like WCF and so forth, right? So again, example of adding packages as part of your Docker file description for a legacy app, very powerful, and then something out of the box that might support your .NET 3 apps. Likewise, we can configure IIS requirements, so there are some handful of things that you might want to configure as part of IIS. There you go. And likewise, you might want to do things like tailor a custom container that is exactly for your app with the features it needs, with the IIS tweaks it needs, with the entry point, some sort of runtime executable that it needs. And again, these are just examples of things you can do, and also showing that we have these, you know, sort of variations of legacy containers available and ready to go as well. Okay. So with that, let's talk about Docker for Windows. So in order for me to develop for Docker, I have to install, you know, the Docker CE on my machine. And the newest evolution of that is Docker CE for Windows or for Mac. So we used to have things like Katana, or Kitomatic, I should say. And we used to have, you know, Docker tools for the Windows machine that ran different ways. So, you know, Docker for Windows and Docker for Mac exist. So on my Mac, I actually have the latest Docker for Mac working. And of course, Docker for Windows is the one that will support me doing either targeting Windows or Linux containers. I can't do that on the Mac. So if I want to do Windows development, I have to buy myself a Windows machine. And not saying I only bought this so I could do a presentation, but let's just say I used to use a Mac all the time. And now I'm doing Docker for Windows because we have more demand for that in our ecosystem. So you need a Windows machine for that, in other words. So I installed Docker for Windows, and that is you know, a single installation, right? It's a native application that gets deployed, and it also integrates with PowerShell or other shells on your system. So I can go directly to PowerShell. It's really easy. I didn't have to set anything special up, and I'm able to run Docker commands immediately. So that's pretty cool. Docker for Windows has a Linux VM. So right now, Linux, if I'm deploying to Linux and testing locally, it's actually running virtualized. That's going to change in the future. I don't have a date for that, but I know I'm allowed to tell you that it's going to change in the future so that we don't have the virtualization step. Right now, I don't even notice the difference, to be honest. It works just fine. So just to know that it's coming, okay? So right now I have a VM, and that helps me execute Linux. I can also look at the mode I'm in by just typing at PowerShell command Docker version, and that'll show me, am I running in Linux, for example, and if I'm running in Linux versus Windows, right? So the client, of course, is a Windows, but down there it's showing that I'm running a server, which is the Linux-based, which means I'm targeting everything I do right now at the command line is going to show me images that I've downloaded for the Linux environment. And it's going to be any containers that I've run that are based on the Linux base image. And I can switch over to Windows containers, so there's a little, you know, toggle for that. So you'll see me using these things. I'm just giving you an overview first. And so once I switch, then I'm going to see that I'm running in Windows. and I can go Docker version and see what am I running at the moment. It's surprisingly difficult to remember which one you're running sometimes, and so if you're doing things like switching between the two, which might not be a day-to-day development task, you will find interesting errors happen because you're not running in the right environment. I'm not suggesting that will happen in any of my demos, because why would I forget? But it could happen, and now you know why. So if I switch back and forth, right, that's how I kind of know what I'm targeting right now. And then, of course, there's Visual Studio. So if I'm building apps in Visual Studio with .NET Framework proper and or AspNetCore or .NET Core, then I'm going to get to take advantage of the tooling that comes out of the box. Not literally a box, but that looks like a box as well. So let's talk about Docker-enabled projects. So I'm in Visual Studio. I want to create a new application. I want it to be Docker-enabled. So what I'm going to do is mostly demos at this point and talk you through things we can do. Okay. By the way, as a point of reference, I have Docker for, I have Visual Studio Preview installed because only just yesterday the preview stuff landed in the mainline Visual Studio 15.3 for 2017. I did not dare to install that the day before a talk. So I'll be using Preview for some things and the regular previous version for others in the essence of having demos that work. I thought you might like that. So I'll mix between the two and I'll explain the differences so that you understand, right? Okay. So I'm going to show you Linux, and of course when I create a new AspNetCore app targeting Linux, then I'm going to have a Docker file that targets a base image like Microsoft AspNetCore. And actually they have multi-targeting base images now. So in the newest tooling you'll find you don't actually have to specify if it's a nano server or not. It gets figured out as the build server takes, as the build container does its job. And so, you know, in some of these demos, I'm showing specifically targeting a version for the base image. I still agree with doing that as a rule, because it can bite you going to production, for example, if all of a sudden when you build, you're getting latest, right? If you don't already have the image on your machine or your environment. So I still suggest target specific versions always, right? That's, as you're doing things. So for what that's worth. You'll also notice that when we look at the Docker file, if you're familiar with Docker proper, meaning Docker without going through tooling and debugging like in Visual Studio, you know, this copy source line and things like that are actually intended so that Visual Studio can allow you to debug, right? So it actually does things like mounts drives, and when you're running, then hooks in and tails the logs into the output window and makes it possible for you to debug. So we would not normally have, you know, a lot of this kind of stuff in our Docker files with source being passed in as a variable, right? So little things like that are just done for you. But what I find is the most important part of that is I still want to be able to create a new app in Visual Studio that's enabled for Docker. I want to be able to debug when I feel like it. But because I'm used to working without those tools most of the time, and because I want to eat my own dog food, as they say, and use my logs as my guide of errors, then I will usually not rely on the debugger for Docker work. So I think there's times when that's extremely useful. And I think that when you get into multi-container solutions, it becomes more complicated to do that. And I think, you know, again, it's an opinion. But being able to just drop down to the command line with the same things Visual Studio generated for you is really helpful and useful to know how to do, so that you're not creating custom Docker files just for my command line experience, separate from the things that I do when I'm in Visual Studio debugging F5. So I'm going to show you that as well. I just thought I'd give you the context up front. So I'm going to create a new app for you know, targeting Linux, and then we'll do the same for Windows. And we'll switch to Windows containers in order to run that. And I'm going to make sure to show you the command line features, some things that we can come back and review after. So let's do that. Okay. So first and foremost, let's do a Docker images, just to give you an idea what I've got on here. And let's also make a point of checking which I'm in. So I'm going to switch over to Linux containers to start with. I was just flipped over to the other. So see, I caught it ahead of time. Okay. You can,
Can you do that in the command line?
I'm sorry?
Can you do that in the command line? Just switch between Windows and Linux?
Not that I know of, no, because it's a native app that's helping you switch, so I don't think so. Okay, so we've got Docker images, and now I'm going to see a whole bunch of different ones, right? These are all the Linux-based ones, right? So that's just to illustrate, you know, I can type Docker version, I can see that I'm running in Linux here. And then Docker PS, see if I have any running containers, doesn't look like it. Docker PS -A, doesn't have any containers running yet. So just to give you that clean slate, here's what I'm starting with. And I'm going to go over to preview. So here is my Visual Studio preview, which again, now this tooling you're going to see is in the 15.3 release of Visual Studio 2017. So I'm going to create a new project, and we'll select AspNetCore application, and I'm going to go ahead and type Docker demos, and we'll call this demo 1 because apparently it is. And now you'll see it lets me decide how I'm targeting, whether it's Linux or Windows. That's a new thing with the latest tooling. What it does, it puts something in the project file that allows it to know which it's targeting. I don't know if that's going to be a long-term thing that stays, but it's something you should know, because that means you can't just change your Docker file and run against Windows without you know, going and editing that project file. So it's probably not a natural thing to think to do. I'm not going to build a container and literally try to multi-target the same app and just switch between, unless I'm doing a demo. So it's not likely that that's going to be impactful. But so right now, that's kind of a new thing that they target. So I'm going to hit Web API, and we'll go ahead and run that. It's going to open up, you know, create the standard API project, you know, API get values type of thing. But it's also going to create some Docker assets for me. So I'll have a Docker Compose project that's created in here. And the Docker Compose project has a YAML, which is describing the services that are part of this composition, right? So when I run this compose or compose up, it's going to say, oh, I have this one image, it's called demo 1, and you know, I'm going to go ahead and build it using the Docker file in the context, which is in the .demo1 directory. So let's go over and take a look at that Docker file. And in here you can see that it's targeting core 1.1 because that's what my template was that I chose. And so it should intelligently choose a base image that's compatible, basically. And there's a number to choose from, right? So I won't get into the details there, but and then, of course, this is what I talked about before. This will allow debugging to happen because it's going to go ahead and mount drives and things like that. And that all happens actually under the cover. So another thing that's changed in the recent is if you used the previous tooling, you would have seen a couple of YAML files that were, you know, layered. You'll see that in one of my examples. Now they've sort of ingrained or sort of built into Visual Studio the intelligence to, when you're debugging, do the things it wants to do without you having to see it. And that way, when you drop to the command line, you know, you're not really dealing with Visual Studio assets. You're dealing with just raw Docker things. So I think that makes a lot more sense. So with that, I've got Docker Compose. I've got a controller. I got go in there and maybe make a breakpoint or something, because that's what we get. And just so you know, it's not running some other app. We'll say, hello, NDC, because nobody ever thought of that in a demo before. And I'm going to go ahead and give that a run. So this will be my, you know, debug experience. It's actually going to use the default network. It's going to generate a port for me. It's going to run under localhost, and it will tail the logs in the output window. So you'll start to see logs after we get past the build process. And so there we go. So I have this API values. And it's just returning a result to show that it worked. And if I type some other specific value, I can jump in here, and I'll get a debugging experience. So you can see that. And continue, and go, right? So I get the result in here. And let's see. Let's go to, stop that. And we'll go back to Visual Studio. I got to remember which one I'm in. So here we go. Okay, so new project, Docker enabled, F5 debugging experience, targeting Linux with a compose file that right now just has one service. I'll do 2 services in a bit. And then in terms of output, if you take a look under build, you can see how they went about building the solution. So basically, if we kind of come out here, let me jump back a bit, and I'm going to scroll to the top. Some of the interesting things that you'll see is that it will do a compose, and I'll just kind of scroll in here. It'll do a compose with multi-file, right? So you can see that it's got the basic compose file, and then it's layering on top of that, you know, the one that says, hey, this is a development environment with an override. And the reasoning around that is to tell Visual Studio also with environment variables, what environment are we running, so that it can inject all those things that we talked about, right, to give you debugging experience and so on. So you can come in here and you can see things like that. If we kind of scroll down a little bit further, it just shows you the resulting compose file after layering. You can see that the volumes are getting mounted, you know, just details that allow the debugging experience to happen. But I don't really want to run in the debugger all the time. So what I usually use compose for is the non-application assets initially. Until we're ready to test our app as a Docker app, I want the performance of just debugging a regular web app, web API, all the things. But I want to hit maybe some server-side data, maybe multiple types of databases that all can run in a container. I could have Postgres, SQL, event store, you name it, a Redis cache, and have all of that sort of running in my command line as a separate part from the solution. And then, of course, you know, when I'm ready and I want to test the application is working still as a Docker container, then I can go ahead and start dropping down and running it as Docker. So I wouldn't do that necessarily for every step of my development. It's something you can think about, okay? I think it really hits you when the solution is big, when there's a lot of files, and it just takes longer, right? Because you've got to build the image and all the things. And I don't like to wait for that stuff, right? So, okay. So let's go back to the command line, and let's do this, Docker images. So now I have an image for demo 1C. And I can say Docker PS, and demo 1 is actually running right now, right? So I'm going to do this, Docker. I'm going to use my magical delete all running containers. And I'm going to show you the experience that I want to have when I go down to the command line. So I've got this new project. And here I am, and I can see I've got my compose files. These are the things that created the project, the DC project, Docker Compose project. So what I'm interested in is, hey, how did it know to build the files? Where did it put the files? And then how did it build the image with the files? Because I need to reproduce that experience. And that's where the CI build container comes in. So what I can do is, let's do this, ci.build. Oops, meant to do up. So now what this is doing is it's taking the CI build, it's going to restore packages on the solution, and then in that container, go ahead and publish the solution. But since the drive's mounted, it's going to publish it to a particular path called object Docker publish. And so that path becomes really important because the things that Visual Studio is doing for you is looking to that path, and it actually has a Docker ignore file saying, you know, that it should allow that particular path to be available. Otherwise, it would not be available if I was trying to build the image, for example. So now I've actually got that set of files built, and that should have created the output in the object Docker publish folder. Now, when I run this, let's do this. I'm going to go ahead and let's take a look at the compose YAML again. And so what we're going to do is we're going to do a build, override. And so Docker compose, I'm going to take the compose YAML, which just says this is the service, this is the image where it is, right? So we've just, this is the source where it is, and this is the image I want to build. It's going to be called demo 1. And then it's going to go over here, and it's going to override with the developer setting if I choose to use that override. So I'm going to hit enter, and what that will do is go ahead and build what was output to the object published. So if I didn't run that CI container first to publish output, the same way Visual Studio is used to doing it, then it's a little harder to use their compose files. And this is not a bad thing. It's just a matter of knowing, I like the command line, dropping down to the command line experience. I can have both perfectly easily. It was just 2 commands, right? So that way I don't have to always be running in Visual Studio. And the other reason that's useful is because I can't tail logs. If the container is running in debug, I'm going to see the logs in the output window. So if I'm interested in actually seeing my real logging experience, maybe overriding and sending it to Elasticsearch or somewhere else, then I need to run it as a non-development environment, right? I'm going to run it from my command line. And I'm going to get that traditional experience. So what I could do now is we've got Docker images, and it's reproduced a new demo 1. You can see latest. 33 is the image ID. And what I'm going to do is do a Docker, Docker compose up. And that will go ahead and run the image. Actually, it's probably running a second one. Let me do this. Docker compose up T. Okay. And I have an image running. It's 2A is the container ID. And if we take a look over here, we can see the port it's running at, which is 32783. And now I can pop up here and say, let's go to 32783 and hit that just like I would otherwise, and it looks like it's working, right? So I can just go back to values, see that I get output, and it's up and running, right? So one of the things I was trying to point out here was that you can, so let's go back over to the beginning, and what I wanted to show you is that you can do a Docker compose logs follow. And so what that will do is follow the logs of all the containers in the compose file. I couldn't have done this and got any output in the command line if I was running in Visual Studio. So again, that comes back to that. I'm in Visual Studio. I'm going to see it in the output window, same development experience I'm used to, F5 debugging. I'm going to drop down the command line. I'm going to see how things run without all of that, with less overhead and with my traditional logging output. Okay? So, okay. Now, that was focusing on Linux. Let's go to Windows. And what we'll do is hit switch to Windows containers. And we'll just go ahead and clear that here. Now, in the past, like I said, before the new tooling came out, I would actually just take the same example, change the Docker file to use NanoServer, and then I could actually build an image for targeting Windows using the same solution. But now we've got a bit more of a targeted solution that when you create the solution in the new preview or the new release, it'll actually target a platform. So I'm not able to do that, which again is not a bad thing. It's just something to be aware of in case you were used to doing that. So what I'm going to do is get out of here and go to demo 1, and let's instead create a new Windows. And the other thing that was not working until recently, which is great, is I can now do Windows debugging in Visual Studio. So that's a recent advancement. So we'll do demo 2. And we'll target Windows. And away we go. So there's a couple of nuances, again, that are different just because it's now evolving, the tooling. I'm going to get the same solution that I had before. I'm going to get the same F5 debugging experience that I did not have before with Windows, so now I get it. And I'm going to have a Docker compose, but you're going to see an empty CI build. That's just because Visual Studio is actually going to do all the work of going and building the published output for you and gathering the correct CI container. So it's starting to hide some of this custom stuff that's related to F5 debugging and running from you so that you don't have to deal with it. It's still, again, evolving. The tooling is getting updated pretty frequently now. So something to be aware of. So if I go to my compose file, you'll see it looks the same as the other one, and now we have compose 3. That's another thing that's an evolution. It used to be that it was targeting 2.1 for Windows in the previous version of Visual Studio until this release. So compose 3 is now available in debug mode. And the other thing that you should know about Windows is that right now, networking requires me to actually specify a network so that we can have communication with the container. And that's also going to change, right? It's going to look a lot more and more like the Linux experience that we're used to. But they're working on some DNS changes. There's some DNS caching issues. There's just some improvements to networking that will allow us to have local host experience. So right now it's going to go to an IP address, which I could go get from the command line, but Visual Studio is now able to do that for me. I used to have to go find it. So I'll show you what that all means, but that's why you're going to see a network defined in the override compose. Eventually, that won't be necessary, okay? And so let's go ahead and run this. So I'm actually in Windows, so I have the new solution. I think I threw a breakpoint in. And again, this is now possible for me to debug Windows as well. So I'm going to talk a little bit more about compose and networking in the talk later today, actually. So right now for this one, I'm going to leave some of those details alone, just so that you know if you're interested. Okay, so this is running, and then at some point it'll launch the browser, and it's actually going to go and find the IP address. But in the meantime, let's go to the command line here, and let's do a Docker PS and see what we've got. Looks like I have demo 2 running. So this 4A is the first 2 characters to describe the container. And you can notice here that it's hitting against an IP address like I told you, right? It's mapped to port 80, so I don't have to see a port at this point. Now, given that, if I was dropping down to the command line and I wanted to know what the IP address was, then I would have to go and find it. So it's helpful to know how to do that. So you can do a docker exec, and I can say 4a ipconfig. And then that will tell me the IP of that container so that I can address it instead of localhost until the fix comes, right? So if I was dropping down to the command line, that's how I would do that. And everything else should work basically the same, right? We have windows, we have logs, we've got breakpoints. So if I go back over to the browser and I hit something, it'll hit my breakpoint, right? So, all right. Okay, so those are pretty simple examples just to sort of kick off. And this is just sort of a reference for you around some of that dropping to the command line stuff that I think people will find useful. We talked about Windows, and what you didn't see me have to do is choose the base image and make it a nanoserver image, because that's actually being done for us. Visual Studio tooling, right? So when they do the build and run, they're actually assigning the right base image on the fly now. So you don't actually see that assignment in the Windows environment right now. So again, new tooling just came out. All that matters to you is that if you want to get explicit with your Docker file, you may want to go in and put a particular version as you're evolving your solution to a particular deployment that should be on version X. So let's talk about adding Docker support then to an existing app. So this is all fine. I can start fresh, greenfield. I can add multiple services to a solution. That's another, I guess, philosophical discussion around, what is the microservice approach to Visual Studio solutions and repositories. And just as a TLDR, I would say, really, the solution should be the microservice. So unless these, services compose together all the time, then they probably shouldn't be together in the same solution. You need a repository. It's a nice clean separation. It helps your dev teams work in isolation like they should learn to when we think microservices autonomously and not depend on one another and not have coupled code. And it forces you to think about how I share code in, say, for example, NuGet packages that have explicit versions that you opt in to download. I could go on about that, but I won't. So that's just a quick taste, just something you want to be thinking about. Now I can take an existing app, and it's got maybe web apps and APIs, and well, you've never seen an app with 97, projects in it, I'm sure. That's probably not going to convert well, just FYI. So you might think about at least compartmentalizing the parts of the solution you're going to Dockerize and start looking at that repository approach. But if, let's say I took a simple example, a web app and an API, and they need to talk to each other, we can now dig into how do we add those things, how do we add Docker to that existing couple of things in the solution, and what does that build for you in the compose description, right? It's going to have multiple services. It's potentially going to have dependencies on multiple services, which we'll see in a later example, and so on. And the other thing we want to talk about are environment variables, of course, because you're probably, if you're running an app in Visual Studio, going to use app settings, and that makes sense. You're running with web config if you're a legacy app, but you're running with app settings if you're a core app, right? And I want to keep doing that because that's natural for the development cycle. And then what I want is, of course, for environment variables to override that if they're present. And I'm not going to, I can make the environment variables and those overrides available just by putting them into the compose file. You can put them in the Docker file too, but it makes a lot more sense to do it in the compose file because that's really the deployment, the deploy and run artifact, if you will, right? That's the task or service description that you're going to be using when you go to container platform. That's going to ship up those overrides to the container platform as well. There's various ways to do that. That's a discussion for the later talk. I'm a bookend today. I have a talk at 5. I have a talk in the morning. So we're going to talk about environment variables and overriding those as well. So let's take a look. So I'm going to go into my web API solution. Here we go. Okay, so this app right now is a web app and API. Talking about app settings, I do have a base address, localhost. It's looking for an API address, right? So this is API base address that it's looking for, and that would be this API, right? So this API has an address described in its launch settings with the application URL. So it's basically, so that the two can communicate. So if I were to run the app without Docker, it'll run in IIS Express. And then I can run the web app, and it will find the API, and everything will work. Or it could maybe not work, and that's another option. Right, let's just go to Docker. Okay, that's weird. It doesn't really matter, though, so I'm just going to go over here. And let's try adding Docker. Keyboard. Okay, so what I'm going to do is add Docker support to this app. So what that will do is generate the Docker Compose project again, generate the YAML, and this is actually using the previous tooling only for the sake of not suddenly using new tooling, all the way through this particular session, just to be safe. So I've got a Docker Compose YAML, and you'll notice that that actually dropped me to version 2, but in fact, it works with 3, right? So I can actually update that if I like. You'll also notice that the Docker Compose, therefore, has these layers that are version 2. So why do I care about the version of Compose? That might be worth mentioning. So the tooling for Visual Studio sits on top of Docker for Windows. Docker for Windows uses Compose 3. That's what it uses. So everything that we want to do with Docker, all the commands that we issue to build and run containers, stop and start containers, compose up with containers, is all working against the Docker, Community Edition, right? That's part of Docker for Windows. Visual Studio on top is really just tooling that generates templates and project assets, and so the previous tooling obviously hadn't caught up yet. So this is just to point out that it's not that there's anything broken with the Docker parts. It's just that the tooling didn't have a template. So So we can easily just go in and edit this. Of course, if you install the latest Visual Studio, you won't have to. So there you go. Okay, so I've got these compose files, and I've got this web app that now has a Docker file. And the Docker file indicates core 1.0 because it picked the right base image, because this happens to be a 1.0. I haven't updated it on purpose, just because that illustrates the choice of images, right? And so now we've got our web app. Let's go ahead and add Docker to the API. And what that will do is update my compose. So we'll say, yes, we want to update the compose. And let's go take a look at that. And now you can see that I've got a web app and I've got an API. Yeah? I don't have to specify the network for Linux. It's just going to work. Speaking of Linux, let's go back there. Thought I'd forget, didn't you? Okay. Okay, so basically with that Docker Compose in place and with the web app and API set up with Docker files, when I do a compose up by hitting F5, it's actually going to run the two. So if I go run, then the one thing that will happen that won't work, right, is this API base address. So the API base address is not in the environment variables yet, so I'll add that after. But I just want to show you the running app first. And I'm guessing it just didn't switch yet. Those are the weird errors you get. So, yeah. I'm going to run that again, just because it might have just not quite been finished with the Windows. See, it's doing a Docker Compose here, and it's stitching together all those compose files, and should be building. There we go. I think it just hadn't flipped fully from Windows to Linux, so you get kind of weird errors in the debugger when you do that. Okay, so this is the app. It's just a website, fake website with a, speakers and sessions conference sort of view. And when I hit speakers, I'm trying to find the API. So the web app's obviously running, and it's containerized. API is also containerized, but it's actually just not going to work because it can't find the address, right? So we'll let that think for a sec. And in the meantime, I'm going to go drop back here, and let's say Docker PS. And we'll see that I've got a web app and a web dev running. Yeah. So in order to fix that up, what I would have to do is, set the environment variables and so forth. And let's go over here. I'm probably going to hit an error, and I'm going to stop debugging. And what we would do is we'd head over to the compose and go to here. And I would add to the web API an environment setting, right? So I'd say environment. And I would say API colon base address equals HTTP, and the name of the actual API by DNS, which is API. So that's what it's looking for now, instead of a port and all those details, because it's going to use the networking from the compose up. So we're going to get the default network created for us, and that's how we're going to address each other through DNS. Okay? And so we give that a run again, and it should be able to find that. So you see it's creating, it's rebuilding the images if needed, and then it's going to run the two containers again. And eventually that will hit over to the website, and there we go. And then I did my job, that should work. I don't know why I'm hitting a breakpoint there, but let's see. Oh, I guess I didn't do my job. Well, this is all part of showing troubleshooting skills, because we need those too. So we're going to head over to here, and I probably just did something wrong. most likely.
The environment setting in the app.
Yeah,
Tell it where the API is.
yeah, I think so. I think I put it in the wrong place. Probably. Yeah. Okay, I'll give that a run again. Ew, no, sorry, wrong address there. Yeah, I think it's the other direction. It's hard to see the tabs in this stuff, so I think it's probably variable. It has to be with the web app, though. Yeah, I think that's at the right level, actually. That's weird. Oh, sorry. Yeah, that's it. I knew that. I totally knew that. I just didn't read it right, so yeah. Okay, so that's going to work, and in the meantime, let's continue. So a couple things I wanted to point out about that example is Compose Up ran the two, basically built both containers, ran the two of them, and put them on a default network, and allowed me to address through DNS, which we'll see works in a moment. It still gave me the debugging experience. I can do the same with Windows, so I won't show that again, just because that would be like a dupe. But let's see. I don't know, that's a weird breakpoint to hit, so that makes me feel like it's not going to work. You suck. Did I say that out loud? I think I did. Yeah, it's going to be something super dumb, but I don't really care, because we all know it's going to work, right? I put quotes around it. Sometimes it takes quotes, sometimes it doesn't. I don't know. Oh, it's web API, not API. That's the other problem. It might help to use the correct address. So, this could totally happen to you one day, so it's really important we go through these things. I'm going to let that run, and let's continue. So when we override environment variables, we don't want them to be secrets. That's a whole other discussion around using Docker secrets. Most of the orchestration platforms now have first-class support for some form of secret management, and then that would be a different way to capture more sensitive information like database, connection strings, passwords, and things like that. So you don't use those for environment variables. But of course, settings like addressing, relative addresses, and things that obviously are not at risk for misuse. If this doesn't work, I'm just going to really shoot myself. Or not do that. But thank you. Oh, okay, right? Thanks. Yeah, that was really painful. Hello world fails? Really? What's wrong with you? Okay, so environment variables. Now, the other thing that we want to be able to do, so we've talked about new apps, we've talked about new apps with Windows, we've talked about debugging, F5 experiences, talked about multiple container applications and Compose Up and doing that with the debugger. I could also drop to the command line and do the same old thing that I showed you before and get my Compose Up with the multiple containers there. And what we haven't talked about is the migration of the legacy apps, but we've shown some container or some images that would give you the baseline for that, right? So you obviously have to start with the right image, depending what your app needs to run. And there could be other things your app needs to care about that are out of the scope of the Docker parts, like where's the database, where do I log, other things that maybe don't go on the container. But as for the container itself, it's really the same experience when you migrate a legacy app. You're going to add Docker support. It's going to create a base image that matches what's appropriate for this app's version. So if it's a 4.5 app, it'll choose that, and so on. It'll enable IIS by default if it's a web app, so that you'll get that out of the box. And there's, obviously some of the same debugging experience out of the box as well. So you will get an F5 and debugging experience with the legacy app too. And it will mount the drives. So this is, again, just showing what one of the Docker files looked like when I did a migration. And the other thing that you can do, and this is where we get back into that developer experience for productivity, I needed a local SQL database for this. What I did is I took a product that I have, but an old version in TFS, just for an experiment. So it's a mess in there. Trust me, it's an old version. And I basically took this Snapboard app that I own, and I migrated that. And it's got a ton of stuff in there, and it just kind of worked out of the box. But I needed a local SQL database, so I grabbed the SQL image and made it so that my compose file included that after the fact so that I can do a compose up and actually have data locally and give that to other devs so we can all work on the code together, right? And so I call that compose up developer love because it's one of my favorite things because we work with lots of different teams and it's painful. So a couple things that I would show you on that. I have that already running actually over here. So this is that Snapboard application, and it's got a web app, which was the thing that I did the add Docker file, which you've already seen, okay? And what you'll see in here is that there are some changes to the Docker file. Instead of showing the servicemon entry point, which you would normally see for the Docker file for IIS, it actually shows this PowerShell bootstrap entry point. I'm going to explain that in a few seconds after I run this, but I just want to point out that this is because of the previous tooling, and there are some new improvements now coming that will allow environment variables to work with IIS in your legacy app containers without having to do this special bootstrapping. So what this was enabling is for me to take any environment variable overrides, and in the bootstrap it says go and put those in the machine level of the container, obviously assuming we're not dealing with sharing and secrets across multi-container apps, and not that. And then we start servicemon. So it was basically a hook to work around something that wasn't available, and the new container or image that they've given us actually supports this out of the box. So just to point that out. It supports it out of the box for everybody but us, because it just turns out that we're using a complex connection, not connection string, but a URL that needs to be encoded, and that seems to be one bug they still have in this new fix. So I still need to use the bootstrap PS for this example, but everybody wouldn't have to. So again, this is about environment variables. How do they work? When I do a legacy app migration, I added the Docker support. It gave me the Docker file. It gave me the compose project. It gave me out of the box something that would start with service monitor, and I could have just put environment variables in my compose file, and it should have worked, but since it didn't, I hooked it with the bootstrap. So all that's, this is already running, so that might be part of it. Or I did it. Who won that bet? I just want to know. Somebody was betting against me. I know it. I forgot to go to Windows. Damn it. I almost had a perfect. Okay. Maybe that was funnier in my head. I find it really amusing, personally. Okay, so that's the kind of error you get when you forget to switch back. So let's do that again. Okay. Okay, so what that's going to do is run the SQL image as a container. It's going to run the Snapboard app. It's going to map the environment variables, which were basically indicating which storage account in Azure do I need to go to get my images that will display in the UI. And so I'm not going to show you things breaking and not working, but you can. I've proven I can be trusted, I think. So it will just launch and work, and we'll see something like this, right? So we'll basically have images being shown in the Snapboard, and this is all stored in the local database that was launched. So, and this will go in debug mode when it gets there, but in the meantime, I'm going to keep going. So a few things to be aware of. I already mentioned. Oops, that's just okay. A few things to be aware of. The new Docker Compose 3 no longer lets you put conditions that check for the health. So I was previously checking that the SQL Server container was healthy before Snapboard ran. So when you do multi-container deployments or compose up. So you don't need that condition anymore. So now the way it works is you just put MS SQL, and by default in a future release of Compose coming soon, it will check for health for you. So you won't have to put, as long as you have a health endpoint in your SQL Docker file, it will respect that. Right now, it doesn't do it automatically, so we're in this limbo period where they don't support conditions anymore So you'd have to write a little custom thing for that. I've given you a reference for this in the slides, so that you'll be able to come back to and take a look. Okay. The other thing is there's a couple fancy things in that sample, like DNS caching seems to be an issue with Windows. Again, there's a bunch of networking improvements that are coming really soon. So things like DNS caching that might get you where containers aren't communicating well, it's going to be, shortly not a problem any longer. So some of these fixes that have references that are well known and documented on GitHub will no longer be relevant. The entry point bootstrap I already talked about, which is the edge cases around some when the environment variables don't map. And then lastly, let's talk CI/CD for a sec. So I've been doing these things locally, right? I'm a developer. I got Visual Studio. I build images. I run them as containers. I test, et cetera. I probably have some logs. I don't, obviously at some point I have to push these images somewhere in order for me to be able to see them deployed to the cloud or to my container platform. And so the way we do that obviously can have many options. I can command line push to a Docker hub. I can command line push to an Azure registry. Or I can do CI/CD, or sorry, the CI part of CI/CD, and actually have my check-in or my commits to Git repo turn into an image, which is a really nice way to set it up quickly. So we have all that, easily working with VSTS. So for example, if I commit or check in to Git or TFS connected to my VSTS account, then it will actually go ahead and pull the latest code, build the image, push that image, and not really sure why this is. I want that to go away, but I can't seem to make it. There we go. Okay. It will push that image to whatever registry I've configured, which in my case is going to be an Azure registry called Michele Busta. The tags will be tags relevant to the registry. That's a bigger topic, but to push to a registry, you have to tag it accordingly so it can be found and pulled by the container platform or by you when you want to run it. So now I've got this immutable image that can traverse between dev, test, UAT, and staging and production, right? So I'm not going to touch it again, only change environment variables. That's the vision. So the vision is that with CI/CD, your deployment environment, dev, UAT, or UAT, which might also say prod if I fix the slide, would pull from the correct tag that would indicate this is the version we want right now. And that would go across all of your images that are being deployed to the container platform. Could be as simple as just a VM that pulls in hosts, or it could be a container platform that's managing many hundreds of images and containers. So the idea, again, behind that is that I should be able to just check in, and I actually have something right here that works. I say that before I demo it because sometimes things do work. And I'm going to go into my ping controller, and I'm going to say, I've got this controller just has an endpoint. I say ping, it says pong, but I'm just going to say NDC Sydney, my demo worked. And then I'm going to right-click and commit. And I'm going to take that one file. So I don't need all these guys, just this guy. And we'll go ahead and stage that. And scroll up to the top. And we'll say updated during demo. Doesn't really matter if I spell that right, but there we go. And then we'll go ahead and sync. And at some point, this is going to be doing an update, but if I head over to here, I should be able to see that this will have queued a build. So I have checked in or committed, and this should kick off a new build at some point. So this is my last build was 275. Let's let that think for 2 seconds, and we're going to go quickly over to Azure and show the repository. This is my Azure repository. The last one checked in was 275. And if I head over here at some point, refresh, it's going to show that it's done. Or did I push? That is the question, right? Did I push? I'm going to go back over here. You might have to push to get that result. I hear that's necessary. Okay, it just pushed. So that means This guy is 276 in progress, so it's going to go ahead, and I have this build definition here that indicates which repository to go to and all that. There's a lot of ways to configure this, but it's just to give you the example that there are some really easy ways to get your images built quickly and get them pushed over to whatever your repo is so that people can use them right away in your environment. So this will go ahead and do its build, and when it's done, we're going to end up with another image over here, and that is that. So what did we talk about? We talked about Docker tools for Visual Studio 2017, that the preview is now actually live, and that I very safely chose to demo between the two of those. We have Linux and Windows support. We have .NET Framework and .NET Core support. You get an F5 debugging experience for both now. You get command line experience if needed, and I told you why I like that. Multi-container build run, so that's another thing that's good to do, not only for your source, but other things that you need to run against, like data backends and things like that. We can integrate with VSTS and build CI/CD pipelines. I just showed you the beginning of that with CI. And at the end of the day, it all works on your machine and hopefully everywhere else as well. And that's all I have to tell you today, so thanks.